Homework problems from section 6.2 in pre-calculus. First one we're going to look at is number 48. We're given those three lengths and we want to find this angle between them. So if we use the law of cosines, 4.5 squared equals 2 squared plus 3 squared minus 2 times 3 cosine of theta. Do the algebra, we'll get that theta is about 127.2 degrees. Problem number 49. Our drawing looks something kind of like this. And there's more numbers in here because some of the calculations have been done, but you have the lengths of 165, 216, and 368. We're trying to find the bearing from point A to point C. In other words, from here up to that point, you're not going north, you're rotating to the east of north, so we're trying to find that angle. If I draw in this segment, so it's parallel to that other one, and I can see parallel, transversal, parallel, so that these two angles are equal to each other. So if we can figure out this angle, then I know the angle on that other side. To figure out this angle, we can use the law of cosines. 368 squared equals 165 squared plus 216 squared minus 2 times 165, 216 cosine of C. Solve all that, and this angle C then comes out to 149.7 degrees. So this entire angle right here is 149.7. I drew in this parallel compared with that parallel, and so this horizontal line, this vertical line are perpendicular. So the right part of this angle is 90 degrees. If we take 149.7 minus 90, that means that the left side of it is 59.7 degrees, which is then equal to the angle we're looking for. So the bearing from Minneapolis from Phoenix is 59.7 degrees east of north. The question asks, what is the bearing from point A to point B? If you go back into this original triangle, triangle ABC, we can use the law of cosines to find this angle, angle A, which comes out to about 13.1 degrees. Or we could use the law of sines once we found that initial angle, and then paying attention to this line and this line, which are parallel to each other. We have this direct line, so parallel, transversal, parallel. Our bearing is going to be this entire angle, which is equal to that entire angle. But I can see from my numbers, it's going to be this 59.7 that we found plus another 13.1. So if we add those two angles together, we get 72.8 degrees. So you're not going north, you're going 72.8 degrees east of north, going from point A up to point B. And this is question number 50. We're given two initial bearings. One of the bearings is heading in this direction with a 67-degree angle right on the north-south axis. Another one we have going in the northwest direction, 53-degree angle right on that north-south axis. And if we look at what's remaining, 90 minus 57 gives us 37 degrees. 90 minus 67 gives us 23 degrees. If we add those together, then this angle between those two is going to be 60 degrees. We have the lengths of 36 and 48. So if we use the law of cosines with this side angle side, we can find the value of C at being about 43.3 miles. This is question number 35. And I have this given information. If I drew the triangle, triangle A, B, C, we have angle A, we have little a, and we have little b, which makes it a side-side angle case. So we would use the law of sines to set this one up. Sine of A over A equals the sine of B over B. We can cross multiply. 4 times the sine of B is equal to 18 times the sine of 24. Next step, we're going to divide both sides by 4. So the sine of B is equal to 18 times the sine of 24 all over 4. At this point, it's calculator, multiply 18 times the sine of 24, divide that by 4, and my calculators tell me about 1.83. Take the sine inverse of that, and all of a sudden there's an error. Since the sine can't be bigger than 1, this is an impossible situation. So there is no solution to this side-side angle.